how to convert an application developed in Preesm to run in the platform, the main core platform Openpiton. I will use a synthetic application, you can see here, and this application is very simple. It's composed of 3 actors, and this is a producer actor, this is a processing actor, and this is a consumer. And we have 2 parameters, message size, here is the size 840, and a slice size. So you can configure a slice size as you want. And the result of the division of message size by slice size will produce the same amount of processing threads here in order to process each slice in parallel. And these applications follows the Preesm methodology already available in Preesm tutorials. So I will not cover this in details. But just to summarize, here we have the application code. So each actor has a .c code, a .c file. So the producer is basically a function, and it produces some random data and print something. The processing will receive this data and will consume here, and will change the value here by a symbolic addition here. And the consumer will let's put this printf to print the value that is sent to produce the consumer task. And we also have the respective header files, consume, processing, and producer. So this is a quite simple application, but its simplicity is good to show how this process of Openpiton, Preesm to Openpiton works. So now I will compile these applications. I will generate the application with Preesm. So I will run the workflow. I will select 4 cores because I will also run this application in a Openpiton many core configured with 4 cores. And this is the mapping. So the core 0 is producer, core 1 is processing, core 2 is processing, and core 3 will receive the consumer. Okay. And if you enter in generated, here we can see the code of each thread, each core. Okay, each is 1 thread per core. Is the same way as Openpiton. Openpiton also can run 1 thread per core. It can run more, but it's necessary operating system, and we don't have an operating system right now. So it only supports 1 thread per core. Once you already developed the application in Preesm, the next step is to validate the application. So I will enter here in the folder of this application. So here I will just copy this. Okay. CD and the directory of the application. I will compile the application. I will enter in code, and I will execute this CMake script. It will compile the application. To execute the application, I need to go to bin release and execute. There is a executable here, and execute the application. So this is the application. Okay, and we have only 1 loop, so we have only one group of prints. Okay, I am simplifying this because in order to execute the application in Openpiton. So if you want to include more loops, you can go to Preesm, include here, preesm.h, and increase the loop size here to 2. Let's just do an example here. So here we have 2 loops, okay? But I will keep one because this will also make the simulation in Openpiton more quick. Okay. Next step, okay, we already validated the application. This application is working in a desktop environment. Now I will show how to convert the application to run in Openpiton. To do so, we could use a script that I developed in the past, and this script comes with the Openpiton distribution provided by Labstick. This distribution is here. Nomen Labstick is in GitHub. Nomen Openpiton. So you can follow these steps. Also, there is a video here. You can see the video and can install the Openpiton environment in your computer. All the steps are here, assuming a fresh Ubuntu 20 version. So you can watch the video or just follow the steps. It's the same thing. And once you already installed the Openpiton, you will be able to execute this command here. Open Preesm to Openpiton. Okay, so you can execute this command from any directory of your system, because this script is already included in the path in the path of your system. So you can this script can be executed from anywhere. Now we have to execute this script to convert this application, in parallel here, to Openpiton. How to do that? So I suggest to go to the Preesm here, the main directory of your application, create a new folder, and can call Openpiton. This folder already exists. Let me remove these files here. Openpiton, create a new folder and call Openpiton, and you can from the I will return to the code to the root directory of Steam Parallel, and we can see here the folders. Okay, and we can call this script Preesm to Openpiton. You must pass the directory where the code folder is located. In this case, is this all directory. We are in the right path. So at the next, we have to select the folder where the generated files will be placed. So you select Openpiton. This script executes, and we can see here that everything went well. Okay, now we can see in Openpiton here 2 files. Okay, one is define, is a file of defines, and another file is the main. So what this script actually does, it goes in all source code of your applications located inside code, and put all the functions inside the .h file. I know that is not the best approach, but it's the simpler one. Put all functions, the definitions also inside your .h file. Here it is. We should change to 1 because we want only one loop, and it also goes to all generated core here and create this Preesm main.c. And these files implements in one file the execution of each thread. So the main thing created by this script is this main function here, and you can see here that basically it gets the core ID from Openpiton. See if the core is 0, it executes the computation thread core 0. If core is 1, and so on. Okay, these print also are inserted automatically. The goal here is to make each core execute the right function in order to execute the right tasks assigned to that core. Okay, so we have these two files. Now we can go to the Openpiton. Here in Openpiton, we have this space here inside. Let me see here. Inside Python, verif, diag, assembly, include RISC-V Ariane and C RISC-V Ariane. We have this place here. Here you should create two files and copy the content of these newly created files to these two files. So I will do this. I will create here a new, actually we have already here, okay, but I will create a new file. I will create here a new file. There is no option here. Let me go here. Oops. I will just copy and paste. I think it's more easy. Okay. And I will call scene parallel.c. Let me delete everything. And here I will copy this, and I will call scene parallel.h, and I will delete everything. So now we can go inside the .h, copy all the content here, and paste in the .h that we just created. Okay. Next step is go to the main.c, copy everything, and put in the newly created file here. So this is the main process. Now we need to handle the problems, the compilation problems that can occur because the script that I developed is not fully autonomous. It cannot completely solve all the problems of the application. So for instance, this stop thread here is something that Preesm adds, and you must remove this because otherwise it will create compilation problems. In summary, the next step is solving compilation problems generated by Preesm. One thing in advance you can do is here change this Preesm defines, because now we create a new file actually, which is scene_parallel.h, and replace it by the right include file. Okay, the other files can be, the other includes can be as they are. So now I will go to the Preesm, Openpiton, sorry, cd noman, cd build, and here I will try to compile our application. So Openpiton, I will create a system of 4 cores, so it's 2 by 2. I will use validator. Okay, if I want to use model scene, I just remove this flag. I want to do everything. I will want to generate, and I want to execute the application. You can see more information in the Openpiton tutorial, and I also want to open the debug tool, the many-good tool. So the only thing to do here is remove this name of the application and put the name of your .c here. So I will copy here and just like that. and I will try to compile. It will gives an error, of course. First, it will try to generate the system. It's generating the system. It's generating the hardware and compiling the hardware. And after it will compile the software. And in this moment, it will generate the error, the compilation error. Because our files, our .c and .h are not completely finished to execute in Openpiton. And I will explain to you how to do this. It's important to note that this compilation of the hardware model is only necessary for the first time. After that, you can execute this Openpiton command just using the run flag instead of the owl flag. Okay, let me pause the video a little bit. Compilation was finished, so we can see here there is a problem. It can recognize the stop thread. So, as I mentioned before, the goal here is to solve the compilation errors. So we return to our .c, and we can remove this stop thread. This is a thing from just use it in Preesm. Stop thread. Remove this stop thread. Okay. Let's try again. But now this time we already generate the hardware. We don't need to create everything. So in order to do the process more quickly, we can just select the option run. Okay, there is another problem here. Stop threads. Let me see. There is a stop thread here. Okay. I will remove this debug because I will only enable debug when the compilation really succeeds. Okay, I think it's already executed. Yeah. So only this was necessary to make our application run in Openpiton after using the script to convert Preesm to Openpiton. So it's important to mention that for bigger application, the main problem will be inside the .h file. So in our case is here. Okay, this file here, or if you want to go to the Openpiton directly, is this file here, which is the same. Basically, I copy and paste the content of one to another. Some applications have a complex structure here, and the script maybe cannot locate the declaration of these structures, or there is another libraries that are used, for instance, for dynamic memory allocation and mathematical things. So your job is to make the modifications in the code to allow Openpiton to compile successfully. So we can, and this is up to you. You can choose to create a static memory instead using memory allocation. You can include a mathematical library here. Okay. One thing that I advise is sometimes we will face a lot of problems with complex application, and we have to play with this file here. Let me see. Python to bin. You have to change this file here and understand this file here. I'm trying to understand everything, but basically this file is the compilation command from software. So this is the GCC flags, and here are the linker flags. And note here that the flag no stdlib is selected. So this prevents the compilation process to use, for instance, libc. And this libc, for instance, have the implementation of memory allocation. But you have to be careful to remove this no stdlib, because if you remove this, you have to make sure that your library is implementing the function appropriately. So for this reason, the Openpiton developers use this option here, because Openpiton is a hardware which have a lot of gaps in terms of support. For instance, there is no memory management unit. There is, but it is necessary operating system to do that, and you don't have this operating system. So this command here is to execute applications in bare metal. Remember that Openpiton can run a full Linux system, so the hardware support is complete. But here, in this moment, we don't have an operating system to run an application. So we have a lot of lags which are supported by operating system, and we don't have this. And for this reason, the applications are compiled with no SDLib. Another thing here, maybe, yes, this is the architecture machine that you are compiling your code. This is already in compliance with the Openpiton. This model of compilation, machine model compilation, is MadAny. I'm not pretty sure if you can change to MadLow. I tried to change to MadLow, but I faced some problems. One thing to keep in mind is that your RISC-V compiler, your RISC-V toolchain is compiled with MadLow, and here I don't know why Openpiton developers choose MadAny, and this I don't know why they choose a different model, but I always use it. MadAny is working. So just to summarize, you have to play with these flags here. I want to, with this, show to you where you can locate these flags to change them inside this file here. Okay. Let's come back to our compilation. So we could see that our compilation is running nice. Now let's execute the debugger. So we can see here the debugger executing. You can click in play, and it takes a little bit, but it is already executed. You can see, you can click over this square, and you'll be able to see the printf of all the threads here. I will open the 4 cores here. So, and it of course is executing in clock cycle accuracy, so it's much more slow than executing in your machine, but we can see that it is executing. You can open the energy and memory profile here. Okay, and there is also tutorials in the GitHub to show how to use this, but I will also show here. You can click in update, and you can see the energy consumption of each core. Oops, we need to stop this to see. You can see the energy consumption of the network on chip, the CPU. You can increase the size, the observation window size to 5, for instance. Let's put 2. And you can see the memory here. L1 miss, L1 access, L1D miss, L2 access, L1 miss, load memory, atomic memory operation access. You can click over the core. Yes, you need to click in stop. And it will show the memory statistics over the time. We can see here that L2 has a peak in the beginning of the simulation execution. After it decreases. Also, the similar thing happens to D, L1D, and after the application fits entirely in the system, it will stop to have miss rate. Same thing for I, L1I. So we can evaluate here the profile of the memory. Have a multitude of options here to select. And the energy, of course. Let me continue here. So this is printing here. printing. So for this reason, we don't see any difference, because it basically is looping in the printf. But just to show to you, I will stop here. Just to show to you that the application is executing properly, and we can see the energy here. Okay. And this, of course, will take different perspective according to different applications. And we can, by using this tool, estimate the energy and memory profiling. You can use the plot generator to plot anything and use it in your paper. It's basically the same option that you have here, but you can use a vector format. You can, let's imagine that you want to see the energy of tile 0, 0. And you want per window, maybe not, but normalize it. This is the energy, basically memory. But let's see core 0, 1. So this is the energy, normalize it, okay. So we can see that there is this profile. You can see that CPU have a bigger importance in the beginning, also knock, but the memory start to dominate. And per window, so this is the energy per window. So here is the energy. If you remove per window, you will see the total energy. Here, okay, the total energy, but normalized. The accumulated energy, but normalize it. So let me remove the normalize it. You will see a increasing graph plot, because the energy is accumulated over the time. But if you want to see this normalized, of course that you will not see this increasing plot. You will see this kind of plot. And it's the same thing for the memory. Okay, memory, you have a bunch of possibilities here to see. For all the system, let's see the L1D miss rate for all the system. And this is the L1D miss rate is equal to 0.771. This is the total miss rate. And if you want to see only for tile 01, you can see. And these plots actually are in a nice format to be used in the paper. So you can basically save this plot here in a PDF or any format that you want. You just need to put PDF here, and save and use in your paper. Yes, I think this tutorial is reaching to the end. Sometimes we have these bugs from the graphical tool, because if you try to open some plot while it is updating, it will generate this kind of error here. Concurrent modification. So it's basically trying to read something while this thing is being updated, and I didn't fix this bug yet. But this is not serious. You just need to click in stop, and after that click over the plot here, and you will not receive the error. Okay, this is the end of this tutorial. Thank you.